So yeah, as Eugene said, I've been doing quantum computing for a long time. It's a very new industry, and so that makes it a good place to try and experiment with structure. We have a lot of needs for public goods, and with Unitary Fund, we've been running a few different ways of trying to fund that over the last few years. There we are. So for this talk, there's really going to be three parts. So I'll try and give you a little bit of context of the setting in which we do the work, and you can view this as an example of a good place to try out new kinds of public goods funding schemes. Then I'll tell you about the experiments that we've been doing at Unitary Fund in particular, and that'll also involve some calls for collaboration around some new ideas, there's some things we'd like some help with. And then we'll go a little bit nonlinear and talk about like science DAO, whatever that means. So what is quantum computing and more broadly quantum technology? So that's the place where Unitary Fund is doing public goods development and has been doing it for the last, say, 4.5 years. So the space is to try and lots of technology that we build on uses the laws of physics in different ways. Electromagnetism is the beginning of electronics and a lot of our computing technology today. But we've known about quantum physics for 100 years, and only recently have we been able to start to make technologies that use all of the sort of special features that are in quantum mechanics. And there's not just one kind of product that comes out of this, and this is important for thinking about the ecosystem. There's a lot of different kinds of things. In the news, you'll hear about quantum computers, but there are also quantum networking technologies, quantum sensor technologies, and so the takeaway here is that this is less about the emergence of one new kind of product or one new kind of computer, and more about a revolution in types of technologies. So it's more like the Industrial Revolution where we got thermodynamics to work, or about electronics getting to work, than it is about the invention of one thing. And just to make it a little bit more concrete, I mean, these are what these kind of things look like. And to echo that point that it's not just about the emergence of one product, even if you just focus on quantum computers, there's not one way to build them. There's not a convergence on a type of integrated circuit. So these are pictures of a whole bunch of different ways of doing it. You can do it with light, which is in the top right. You can do it with ions. You can do it with these chandeliers of computing, which show up in the Dev's sci-fi show. Those use superconducting circuits. So because of this, there's a whole bunch of different platforms that need to get developed that are totally new. To help make this happen, there's been a lot more funding over the last few years into the space. So there's big government programs for basic research. There's been large increases in the amount of private funding. So there's been more funding in just like the last year and a half than in the entire history of society so far. And there's all sorts of things that we eventually want to do here, but there's a big way to go. So if you start to look at research about the kind of specs for a quantum computer that we need, or the kind of computer that we really want, it's things that have thousands of logical quantum bits, lots of memory, they can do millions of operations, and we're kind of down here in the bottom left, where we can have tens or hundreds of quantum bits that have tens or hundreds of operations. So it has a lot of potential, but it's still early enough where we can start to influence how that industry develops. And Juan talked about this kind of early on, earlier today, that when you're early on in industry, you can influence how it develops to instill different kinds of values. And so that's one of the things that we've been doing. The other thing I want to let you know about is just to get a bit of a sense of the scope of this space. And I think if you're going to try different kinds of public goods experiments or try different kinds of community building things, it helps to start in a small niche. And in quantum computing, that niche is already pretty small. We're talking like thousands, tens of thousands of people globally who are really working in this. So you can have a big impact with small communities. So I've told you about this rapid growth of public funding, a rapid growth of VC funding. What's been missing, and really what's missing, is all of this common stuff. So we're talking about open source programming languages, developer tools, education and training, mentorship networks, benchmarks, standards, all the stuff that makes it really cheap to make regular software today on regular computers doesn't exist in quantum. And who's going to build this? It doesn't fit very well into private VC funding models, and it's not academic papers, it's systems. In fact, I talk about this as commons goods, but I even more than that like this idea of network goods that Evan Miyazono talked about this morning. Because a lot of them are things where the more people that use them, the better they are. So they're not just, they sort of, what did he call them, anti-rivalrous. So that's what we do. And so Unitary Fund's a nonprofit. We're 501c3. We work globally, and we've been around for about 4 years. And so it's a new organization to try and build these robust open source goods. And right now, we're funded mostly by key corporates and players in the space. They recognize that if you want to put out open source software and get the benefits of that, there has to be some kind of open source software engineering community that's going to contribute back. And so how do you get that started? And so, over the last few years, we've been galvanizing different folks. This list includes big companies that do quantum computing, startups that have just started, VC funds that focus in it, these kind of areas. So what do we do with the funding and support that we have? I'd say there's like 2.5 sort of major programs that we run. The first is a microgrant program, which is actually what we started with. We started with a blog post that I put out where I said I'd give away $6,000 in 3 microgrants to people to build something in quantum technologies. And we've grown from there. And then secondly, we have an in-house research lab that builds bigger types of things that we can't fund on open source grants specifically. And then of course there's a community component. Discord, we just finished a hackathon where instead of having people build things from scratch over a weekend, we got a bunch of maintainers from open source projects in the community to tag open issues on their repos with bounties that then folks would close over the course of the hackathon. So a little bit about the microgrant program. We funded about 54 projects in over 20 countries. There are startups that have come out of this, even though that's not been the focus, and also nonprofits, and kind of all for the cost of, a graduate student throughout their whole program. And so this is kind of an example, I think, of how effective microgrant funding can be. That's not just about the dollar amount. It's not just about how much money you're putting towards something. It's about how you're allocating it. And as Alexandra, who's one of the winners of these microgrants, talks about, the support that you get from a grant program is not just the money. Like, the grant program is an entryway into a community, an entryway into mentorship, an entryway into having a stamp of approval that says what you're working on is worth working on. And that means a lot for someone's career. So I want to tell you a little bit about the process that we've used for these microgrants so far. So right now, we do turnarounds that are pretty rapid, either twice a month or once a month. And the way we structure it is we have it based a little bit analogously on how a VC fund works. So we think that open source microgrants are kind of like venture capital in the sense that it's an outliers business. You're not trying to have a low probability of failure. You're trying to have a few projects that are extremely successful. So how do you set up a grant process that supports that? And this is how we do it. We call it sort of like a champion process rather than a consensus one. So we meet, and we need at least one person or 2 people to act as sort of what you think of as like the VC who's joining the board, but in this case, it's someone who's going to take on the mentorship role one-on-one with that project to help ensure its success. And so we're biased towards funding things. We'd rather not fund things where there's like a mild consensus that this is a good idea. Like, that's okay. Better is something where there's dissent, but some small minority that's extremely vocal that thinks that we should fund this, right? And the kind of criteria, lining up with our mission, projects where our support can make a difference, and where there's good people involved. And so the reason that I want to talk about, we'll come back to this, but the reason I want to talk about what our process is when we look at scaling things out to other kinds of grant programs, they don't tend to have this quality. Like, if you do token voting, for example, that explicitly prefers like average preference versus a vocal minority sometimes. So we'll come back to that. Okay, so the other thing we do is we do open source development in-house. And so here you can think about what we're doing is pooling funds from different stakeholders in the ecosystem and then funding independent open source work. So we've built like a pretty well-used open source compiler. Qtip is a project that actually predates our founding. It's about 10 years old. It's the quantum toolbox in Python. Think of it as like NumPy for people doing quantum information stuff. That's really well used. And not just software, but also recently we launched a platform for hosting community-driven benchmarks. So think of it as like MLPer for papers with code for our field. And I want to call out benchmarks. Actually, tomorrow, David Lang is giving a nice talk just about standards. When we think about things in the commons, standards and benchmarks are extremely, extremely important, not just open source technology or communities and stuff. So one of the reasons I'm here, and one of the things that I'd like to get out of conversations today, are to think about ways that we can scale the stuff we're doing. So if we don't want to give out 180K, we want to give out 1.8 million. If we don't want to fund 20 projects a year, we want to fund 200. How do we do that? And so, more dollar amount, more projects is one way to go. But another way we want to go is we want to help the community that's gotten started around this be more involved in governance. We can look at experiments of things like funding retroactively, and sort of, I don't have a lot of time to go through everything that we've considered, but we've been looking at a lot of the options so far, and definitely have looked at different kinds of DAO tooling options. But in looking at it, we've landed on what we're probably going to do next is experiment with governance, but in a centralized way. If anyone has alternatives to convince me, I'm happy to talk to you later today. But the main reason in our exploration has been that our community is hesitant about financialization. And if you have some kind of tradable, sellable token, then you really, you have less trust. You need to have some kind of decentralized system. But if you're not doing financialization, then people are pretty happy to stick with a centralized system. So then we don't have to take on the UX burden of switching to Web3 stuff. But we'll see. I've heard lots of talks about Web3 tooling and today, and I think eventually there'll be more stuff to play with here. And I'm actively looking for input on this, so feel free to reach out at any time. So now I want to take a little bit of an exploratory turn to this last bit of the talk. And partially because Unitary Fund is a bit of a different kind of research organization. It works on things that aren't blue skies, academic pure research. It's not stuff that's ready to be commercialized in a VC environment. It means that I've sort of just been thinking about this chasm in between those two, and what are the things we can do to help make science work better in that space. So let's talk about a very famous commons, science in general. And one thought that keeps popping into my head about it is that science is already a DAO. Right? You don't get employed by Science Corp. You work at some research institution that gets funded, maybe by your country, maybe by a philanthropist, by someone else, but it's a shared project where there isn't some single institution. But it's definitely ready for an upgrade. So science is a supranational community of decentralized researchers. And in fact, it even has a token that's in many ways socially accepted, which are citations. But they're really pretty bad as far as social tokens go. They're non-transferable, there's no governance rights, and they're totally unweighted. And we'll talk a little bit about that. But I think one way, if we're trying to get more people who do science interested in the kinds of things you can do with new kinds of governance technologies, then acknowledging that they're already pretty decentralized is a good place to start. And so the next few slides, I'll talk about sort of this, what's the difference between where we are now and where we could be. So today's Science DAO at RU is a legacy organization. So there's only one way to mint these citation tokens, and that's by writing a new science publication, which sometimes, in order to mint, you have to come up with new human knowledge that anyone has ever discovered before. That's a pretty high barrier to mint a new token. And it results in a paper glut, I think. A lot of what people are trying to do is just say, I'm interested in this area, and I think this work that is in this area already is also interesting. And so they kind of write a paper about it. It would be a lot more effective for me to just take my science social token and transfer it to the person who wrote that paper than writing yet another minor contribution. The second is that the allocation of science funding is slow with bureaucratic overhead. And I think we all know about that. And a lot of the problem is that funding is almost exclusively grant-based and not retroactive. So you get competitive and exclusionary dynamics. People spend a lot of time writing proposals that don't get funded, and that ends up being wasted. It would be better to look backwards and fund what has already been determined by the community as useful. So what could this maybe look like? And so I'm going to say something that I don't think we should actually do, but it's worth thinking about as a Gedanken experiment for why we shouldn't do it. So you could imagine a science funder who just took a subfield, let's say quantum technologies, and they looked at the citation graph that already exists. And then they pick some graph metric that they like, pick high-degree nodes, and they have some pool of money, and they just give it to people who already have lots of citations there. You'd probably say this is scary. It would probably just entrench people who are already doing good things. But one of the reasons it's scary is that citations are a bad token for determining who is socially able to do good things. So if we improved how citations worked, then this would potentially become a more, looking just at this distribution of citation tokens, if they're improved or upgraded, could be a better way of looking at how to allocate funds. So one thing that you should definitely do, or you should be able to weight citations across references. So when I write a new scientific paper, I can only give one citation token to each paper that I cite. One of my references is probably the key one that all of my work depends on, and the other 10 are there, because if I don't put them there, someone will yell at me. And those should be given like a different weighting in transference. You should be able to trickle these down through the citation graph. So like there's sometimes what happens is you get a really good paper that founds a field, but it's kind of obscure, and then another paper figures out that that was important and explains it. And the second paper is the one that gets all the citations, not the first. And so there should be some way for me to say, if you cite my paper, half those citations should really go to this other one that I secretly depend on. That's programmable. You should be able to transfer tokens without needing to write a new paper. And if you do this, then you might establish an ability for people, like a role for people who are re-granters, kind of like a scientific equivalent of VCs. So instead of giving money explicitly to people who, let's say, have a lot of these citation tokens, you could give them money to re-grant. And then they could get some carry based on how many. You could sort of just do a simple. I'm running out of time, so I can't walk it through. But you can run carry off of how they then distribute that funding relative to how citations then come on from those. And finally, you could reduce overhead if funding organizations can just look at this graph and send checks. There's no proposals. I mean, you don't want to fund everything like this, but think of this as just kind of like a thought experiment of something that we could add on to how science happens already. All right. So we covered some ground. I'll be here for a couple days. I'm looking, you all are interested in different kinds of public goods funding. Quantum technologies, the structure we have set up, we can do experiments. The people who fund us want us to run experiments. We have a lot of flexibility. Come pitch me on something we should try. I'd love to hear about those ideas. Or if you just want to talk about science stuff, come find me too. Thanks.